Okay, so welcome everybody to the lesson 15 video on piecewise functions. This is the first video starting the new unit of piecewise functions, and we're going to kind of delve into those functions today. Just kind of the tip of the iceberg type thing for today. But let's start off with some opening exercises here. It's classwork, so we'll just pretend that this is what you're going to be doing at home. All right. So the directions say for the opening exercise, for each real number a, the absolute value of a is the distance between 0 and a on the number line and is denoted by absolute value of a. That's what that means there. That's the absolute value of a. That in essence is the definition of absolute value. Okay, that is what the absolute value is. So let's solve each one variable equation. All right, so for letter A here, we have the absolute value of x equals 6. All right, so how do we solve an absolute value equation here? Well, basically, if you think about the values of x here that could fit, x could equal -6 and x could equal +6. All right. If you think about plugging those values into that function here, when I plug in -6 there, it gives me 6, and obviously so does +6. So hence, x equals -6 and x equals +6 are the two solutions for letter A. All right, and that's a really important point because we're going to use that same concept to solve B and C, which are a little bit more complicated. So let's take a look at B here. We have absolute value of x minus 5 equals 4. Okay, so to solve that, I actually need to solve x minus 5 equals 4, and then I have to solve x minus 5 equals -4. Okay, which if you look at what we did over in A, it's the same. We're following the same idea. Okay, so when I solve the left equation here, I'm going to add 5 to both sides, and I get x equals 9. On the right equation here, I add 5 to both sides, but I get x equals 1. So I actually have two very different answers there. I have x equals 9 and x equals 1. And remember, whenever you're solving an equation, I always, you could check outright, or I like to just quick do a little mental check. When I plug in 9 for the equation here, 9 minus 5 gives me 4, and of course the absolute value of 4 is 4. When I plug in 1, okay, 1 minus 5 is -4. Absolute value of -4 is 4. So those are my two solutions. All right, moving right along. I got to try and keep pace here because, this is a rather lengthy lesson, and we don't want to make it too long for you guys at home. Not that you guys have anything better to do. No, I'm just kidding. Of course you have something better to do. But anyways, all right. I'm really the one that doesn't have anything better to do, as you can see here, because I am doing this right now. All right, moving on. Letter C. 2 times the absolute value of x plus 3 equals -10. So solving that, I don't quite set it equal to, actually here, let me see here. Oh, I see that I've done something foolish. All right, so when I go to solve this, you can go ahead and divide both sides by 2. Okay, divide both sides by 2. I get absolute value of x plus 3 equals -5. Okay, now when I think about that, okay, solving that, I come to a little bit of an issue here because an absolute value of something cannot be negative. So when I'm taking the absolute value of x plus 3 there, and I'm setting it equal to -5, that's just never going to happen. I mean, how can we get an absolute value to be negative? I mean, you know, let's just say you did happen to solve this. Let's say you subtract 3 from both sides, subtract 3, so I'm going to get x equals -8. Now, if you think about plugging that -8, okay, into the solution, we in fact get -5 as my absolute value. Okay, just bear with me here. So -5. The absolute value of -5, however, is not -5. It's 5. So there is no solution for letter C. No solution. You can't have a negative absolute value unless if you ever had something like this. Negative, let's just say x plus 3 equals -10 there. Okay, now that can be solved because I would divide this by -1 first, divide this whole thing by -1, divide this by -1. I get x plus 3 equals 10. Now we're back to the positive realm, which of course can be solved. So, you know, make no mistake, whenever they say absolute values can never be negative, there is a, you know, you can get a negative answer, but when you take the absolute value of something, you are finding a distance, and distance cannot be negative. Therefore, absolute value of x always equals a positive value, a positive real. Okay, and like I said, if you put a negative out front, well, of course that changes things, but the idea of the absolute value being a distance is always something you should understand. Okay, and of course when I say distance, I'm saying distance on the number line, right here between 0 and a on the number line. Okay, so there's a little intro. Moving right along. Determine at least 5 solutions for each 2-variable equation. Make sure some of the solutions include negative values for either x or y. So we're going to go pretty quick here. Some solutions for this, we'll call it x and y. We can go -1, 0, 1 for this guy. And that's, of course, the absolute value of -1. You know, if I was doing this, y equals absolute value of -1. So then y would equal 1, of course, because 1 equals absolute value of -1. So this is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. So there's some values for that. All right, some values for b. We could do, let's just say this, x, y. Let's do -1, 0, 1, 2. Let me think here. Yeah. Okay. So we're going to have, if we plug in -1, absolute value of -1 minus 5 is the absolute value of -6, which is 6. So -1 is going to give me an absolute value of 6. -2, oh sorry, 0. 0 minus 5 is going to give me -5. Let's do that one over here. 0 minus 5 is going to give me absolute value of -5, which is 5. Okay, so 0, 5. 1 is going to give me absolute value, absolute value of 1 minus 5, which is going to give me -4 absolute value, which is 4. Okay, so 1, 4, and 2 is going to give me 3, and then 3 is going to give me 2, etc. So there's some values there. And then last but not least, this function, or this this equation here, x equals absolute value of y. This is a little funky here. All right, be careful because we're used to this x, y input-output idea, but what you actually want to be inputting here is y values. So let's use some y values. -3, -2, -1, 0, 1, 2. You can do 3 down there too. -3 absolute value, so the x value is going to be 3, because the absolute value of -3, meaning the y value, is going to equal 3. So the x value, the output is actually the x value, which is 3. All right, absolute value -2 is 2, absolute value -1 is 1, absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2. So there is that. There's some sample values there. Okay. So now what they want us to do is graph these. So real quick, let's graph these. Okay. Letter A was the absolute value of y equals the absolute value of x. All right. So x, y. We'll do -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, absolute value of -4 is 4, absolute value of -3 is 3, 2, 1, 0, 1, 2, 3, 4. Okay, pretty straightforward. So we're plotting that. -4, 1, 2, 3, 4. -3, 1, 2, 3. -2, 2. -1, 1, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Okay. I go ahead and plot, that. Okay. And that. Oh, that line wasn't that good. I'm gonna delete that. Oh wait, I can't. That's right. This thing is annoying. All right. Actually, let's try this one. Okay. Undo. Edit. Undo. Edit. Undo. Okay. Good. All right. One more try. See if I can get that better. Okay, a little better. All right, there's that absolute value. Of course, we'll label y equals absolute value of x. All right, and you can put these arrows there. Okay. Now, for letter B, the function was y equals absolute value of x minus 5. Okay. So, we're graphing that. Okay. And so this will be x and y, okay? And I'm going to use 0 to 10 here. That's my value, so I'm going to use, I'll do -1. So -1, 0, 1, 2, 3, 4, 5, 6, 7. Yeah, that's good. I'll use that, okay? And the reason I'm doing that, you'll see, okay? But I happen to know that this absolute value here, is absolute value v that is shifted to the right. That's shifted to the right. And I know that because I'm simply a genius. Okay, we've talked about this in class before, and I'm pretty sure everybody can agree on that. So, yeah. So, just one thing over here on this left graph, by the way, I want you to understand that is this section here. You don't have to write this down, but that V is going through the origin. All right. Okay. So, moving on, plotting this. Okay. Putting in my x value, -1 minus 5 is going to give me -6. Of course, the absolute value of -6 is +6, so this is going to be 6. 0 is going to give me -5, which of course the absolute value of that is 5. 1 is going to give me -4, which of course is 4. 3, 2, 1, 0, 1, 2 is what that outputs are going to be there. And so I'll plot that. -1, 1, 2, 3, 4, 5, 6. Okay, 0, 5, 1, 1, 2, 3, 4, 2, 1, 2, 3, 3, 2, 4, 1, 5, 0, 6, 1, 7, 2, 8, 3, 9, 4, 10, 5, etc. And there is this absolute value, which of course is y equals absolute value of x minus 5. All right. There's that. Okay, any questions? Oh, that's right. You can't ask any. Okay. Alrighty. So moving on. Those are absolute value graphs. They look like V's. Okay. Just real quick. Okay. The big concept, the big misconception that a lot of students, I shouldn't say that. The big mistake that students make with absolute values, okay, is they don't plot the V. You have to understand this big fact, okay? For all intents and purposes, for everything that we're going to do, the absolute value graph is going to look like a V. So I always say absolute value looks like a V. The value V. So make sure you get a V. what I want you to try and understand here, okay, is let's say you were plotting B here. Okay, let's focus on B. And let's say you weren't a genius like myself and you didn't know that this graph shifted to the right 5 units. So more than likely you're going to plot from -5 to 5. So I want you to see what kind of graph. I'll plot it here for you. Okay, I'll change my color. Ooh, look at all these sweet colors. I'll do strawberry. What I'm going to plot here is what you would plot if you plotted -5 to 5, and this is what you would plot. Okay, you would plot this. Oh, strawberry was not a good choice. Oh, we're done with strawberry there. Let's go back to our boring colors, and we'll do this. I see that my students have been messing with the board, but hey. Okay, so here's what you would plot if you plotted -5 to 5. Well, I'm plotting it in orange. Okay? That's what you would plot. Okay, and you'd think, hey, that's fine and dandy. I'm just going to draw that line, and there is the line y equals absolute value of x minus 5. It's right there. There it is. I plotted it. Of course, the problem is you didn't actually plot y equals absolute value of x minus 5. You plotted y equals x minus 5. Okay? Because you did not continue your domain. You did not use an expansive enough x domain. Right here. Okay, see how expansive that is? From -1 to 7. Why did I do that? Well, because I knew it shifted to the right, and I wanted to get the v component of the graph. If you do not plot the v component of an absolute value graph, you didn't really graph an absolute value. Okay? All right. That was a little bit of a ramble, but what are you going to do? It was worth it. Okay, moving on. We got the last graph here, which is of x equals absolute value of y. This is quite the interesting graph. Okay, and just real quick, what that's going to look like is do the table. Okay, I'm just gonna kind of move now because I don't want to take up too much of your time. 1, 1, 1, -1, 2, 2, 2, -2, 3, 3, 3, -3. Again, we're inputting y values, outputting is x. So the 0, 0 value works. Absolute value of 0, 0. Absolute value of 1 is 1. So we're still getting this component here. Okay? But what's interesting is, what about 1, -1? Let's plot that. 1, -1, that goes right there. Okay, we're plotting that point. 2, -2, 3, -3, 4, -4, 5, -5, 6, -c. So this is what you end up getting. Okay, so you end up getting this sideways v. Oops, it's not y equals, it's x equals absolute value of y. And of course, your calculator is not capable of graphing that, because your calculator can only graph in the form y equals. So, anyways, there's that function. Sorry, it's not a function though. That's the equation x equals absolute value of y. Of course, it's not a function because it doesn't pass the vertical line test, because x values have 2 y values. For example, the x value of 1, as you can see here, the x value of 1 has a value. The x value of 1 has an output of 1 and also -1. So x 1 goes to 1, but it also goes to -1, therefore it's not a function. All right. So comparing and contrasting some of these graphs, of the 3 solution sets, what we have, just as a message, and you can get some more detail on this on the completed notes, but the bottom line is that the graphs are all examples of absolute values, okay? But this last one here for letter C was rotated 90 degrees, and as I said, it's not an example of a function. The other 2 were functions. The one was just a regular V, and the other one was, the one was just a regular V like that, and the other one was shifted to the right. Those are still functions, but this last one, letter C, is not a function, okay? you might say the vertex of this graph here, the vertex shifted to the right 5 units, which was the main difference. Okay, moving right along here. Consider the function f of x equals absolute value of x, where x can be any real number. Explain the meaning of function f in your own words. Okay? F. Okay. Okay. So f is defining. F is the function that takes the absolute value of the input. Okay, I mean it's about as straightforward as you could say. And just remember that the absolute value is actually the distance from 0 on the number line. So if I input 2, the distance is 2. If I input -2, the distance is still 2. Okay? So what's the domain and range of f of x equals absolute value of x? Okay? Well, my domain. What could I put in for my x values? All right. What can I put in for my x values? Well, there's really no limit to what you can put in. Okay, x is real. All right, you can put in negatives, you can put positives, decimals, irrational numbers, whatever. You can put anything in. But the range, i.e., what f of x will equal, okay, is not anything. Okay, the range is, we'll say, f of x is real, such that f of x is greater than or equal to 0. In other words, non-negative real numbers. Non-negative reals. Because, again, the absolute value is a distance. And distance is not negative. You can have distance of 0. You could have distance of pi. You could have distance of square root of 2. You could have distance of 12 feet, whatever. But you can't have distance of negative 12 feet. Okay. Create a graph of this function. So let's create a graph of f of x equals absolute value of x, which of course we'll get to in a second, but we'll just start inputting x values. Let's just start with -3, -2, -1, 0, 1, 2, 3, which is y value, sorry, it's actually f of x, which of course is basically the same, but absolute value of -3 is 3, absolute value of -2 is 2, absolute value of -1 is 1, absolute value of 0, 0, 1, 1, 2, 2, 3, 3. So we plot those points, and hopefully this is, as you understand, you understand that this is the same graph as what we've just done with y equals absolute value of x, except as f of x equals absolute value of x, which of course really isn't any different. Okay, so there's the function. All right. So for letter H, how does the graph of the absolute value function compare to this graph? Okay, letter G. Let's go to the next page. So how does this graph of the absolute value function compare to that? Well, they're basically the same thing. Okay, the two graphs are identical. You know, you can essentially replace y with f of x because y is a function of x. That's what that's saying. So they are identical. Okay. Define a function whose graph would be identical to the graph y equals x minus 5. That's easy. F of x equals x minus 5. Absolute value, of course. Okay. All right, and letter J, could you define a function whose graph would be identical to the graph of x equals absolute value of y? And that's a tricky one. All right, and unfortunately, that is not a function, so you can't define a function whose graph would be like that. The graph x equals absolute value of y does not meet the definition of a function. If it were a graph of a function, it would be the set of order pairs. It's just not a function. Okay, I mean, I don't know. You pretty much the problem is, if we're defining it as a function, it means it has to have a y value, one y value for the x values, and as we saw when we graphed this, this is what it looked like. So clearly, every x value does not have only one y value, so we can't define it as a function. All right. Trying to think if there's a better way to explain that. Yeah, I mean, like I said, if you just think about it, it's not a function because there are repeated y values for each individual x. All right, for example, like I just said, let's just do one more example. Let's just say the x value of 4, okay? Well, the x value of 4 is associated with the y values of -4 and +4. Those are the y values. So, you have this, and you have these in the same graph. Roughly 4, 4, let's just say, is right there. 4, -4 is right there. Okay, they fail the vertical line test, i.e., it's not a function. The x value of 4 has 2 y values. Okay. All right. Last but not least, we're going to do this little piecewise bit here. All right. Jeez, this is. All right, we're going to keep trucking on. Bear with me here, okay? I know this video is long, and I'm going to be working on these to try and make them as short as possible, okay? We got only a little bit more, so just bear with me because I want to be able to do the homework tomorrow with you guys in class. And we really can't do the homework if we don't get through this last part. All right, so real quick. We're talking about a piecewise function here. We got f sub 1 of x is negative x. And f sub 2 of x is positive, or is x for x is greater than or equal to 0. So real quick, okay, f of 1 is going to be this. I'm just going to plot it because I want to get through this quickly. Okay, this is f of 1, f sub 1, because when you, let's just say we plug in, it's only negative x's, so let's just say -3, -2, -1, 0, 1. Sorry, we can't. So those three negatives, okay? Well, y is the negation of -3, so it's going to be 3. And the -2 is 2, okay? And -1 is 1, so you end up with this f sub 1. And then f sub 2 is this, okay? Because it's just x, and it's for a positive x values. So you got 0 and equal to 0. So 0, 1, 2, 3, etc. And of course the y is just the same. So you get this f sub 2. So basically this is a piecewise function. When graphed, we actually get something that is identical to an absolute value. So what they say down here is the absolute value function is defined by f of x equals absolute value of x for all real numbers. Another way to write the function is express it as a piecewise function using negative x and x as shown there. Okay. All right. Here's another example showing you that an absolute value is really just two pieces or it's really two lines pieced together with limited domains. So this line has a domain of x is less than 5, and the other line has a domain of x is greater than or equal to 5. And together they piece to make the other absolute value, g of x equals absolute value of x minus 5 that we graphed before. Okay. Okay, now exploratory challenge 2. The floor of a real number x denoted, we'll just call that floor x, is the largest integer not greater than x. The ceiling of a real number x is denoted by ceiling, is the smallest integer not less than x. The sawtooth of a positive number is the fractional part of the number that is to the right of its floor on the number line. In general, for a real number x, the sawtooth number of x is the value of the expression x minus floor of x. Each of these expressions can be thought of as functions with domain the set of real numbers. What? So what are they talking about there? Okay, so this is the last bit of the lesson. The floor is the floor of a real number x, denoted by floor of x, is the largest integer not greater than x. So let's take a look at 4.8. Okay, what's the floor of 4.8? Well, the floor of 4.8 is the largest integer not greater than 4.8. What's the largest integer not greater than 4.8? 4. Okay. Now the ceiling is the opposite. The ceiling is, as shown, the ceiling here is the smallest integer not less than x. So for 4.8, what's the smallest integer not less than 4.8? 5. Okay. Now the sawtooth, which we'll talk about why it's called the sawtooth in a second. Actually, more like in a minute. But the sawtooth is the floor. Sorry, the number 4.8 minus the floor, which of course is 0.8. Okay. Now negative 1.3. Okay, so we'll do this real quick. The floor of negative 1.3 is negative 2. The floor of 2.2 is 2. The floor of 6 is 6. The floor of 6 is 6 because there's no decimal. We're going to the nearest integer. The floor of negative 3 is negative 3. Now negative 2/3. That one's tricky. Okay, negative 2/3 is negative 0.6 repeating. If you want to think of it as a number, it might be easier for you as a decimal. But negative 2/3 repeating, negative 0.6 repeating, the closest integer that's smaller than that is negative 1. And of course, pi, the closest integer, is 3. Likewise, the ceiling, 5, negative 1, 3, 6, negative 3, 0, 4. Okay. The sawtooth is the difference. Okay, so that's going to be 0.8, 0.7 here because we're taking negative 1.3. Yep, we're taking negative 1.3 and subtracting negative 2. Okay, and that's going to equal 0.7. This one's 0.2. 0, 0 for these, of course, and this one's 1/3, and this last one is pi minus 3, which of course is in itself irrational. But anyways, there's those values, and now the last bit of the lesson is graphing these. Okay. I'd like to do this in class tomorrow. I feel like the video has been over a little bit too long, so we will do this in class tomorrow. All right, we'll start with this bit tomorrow. We'll do it for about 5 to 10 minutes, and then we'll work on the homework in class. Okay. Thanks. Have a nice night.